I think we can get started. Well, hello everyone. Thank you for attending today's webinar, The Evolution of 2D Based Maps into Digital Twins for Smart Government Initiatives. My name is Amy and I'm the Membership Associate at the National States Geographic Information Council. If you are unfamiliar with our organization, NSGIC exists to advance effective national coordination of geospatial information by supporting state-level cooperation. We serve as a national forum for the development of capable and future-oriented geospatial leadership. If you'd like to learn more on how to get involved, please visit our website, www.nishjik.org. I will pop that into the address chat box shortly. Some reminders for today: all attendees have been muted on entrance. There will be time at the end of the presentation for Q&A, so please place your questions into the chat box. They will be answered and read aloud at the end of the presentation. Additionally, a recorded version of this webinar will be made available afterwards, so be on the lookout for an email with that information. With that, I'd like to introduce today's presenters. Sarini Dharmapuri, Vice President, Chief Scientist, Jason Caldwell, Vice President of Business Development, and Jameson Quisenberry, Associate Project Manager. I will now turn it over to the presenters, and thanks again for joining us.
All right, thanks so much, Amy. This is Jason Caldwell from Sanborn. So we appreciate everybody joining our call today, and we appreciate NSGIC for making this type of marketing available to Sanborn, as well as the people that are interested in this subject. So we're excited to present, and we'll jump right in. So in terms of our agenda today, we're going to talk about Sanborn and the digital twin and kind of the concept that I've been thinking about in terms of how Sanborn and the digital twin have been evolving over the years. And then we're going to hand that over to Srini. He's going to talk about how we build the digital twin. We'll talk about geospatial input data, geometry capture, texture capture, and interior mapping. And then the big thing is we'll talk about use cases, right? That's always the big idea, is how do we get a return on investment on this technology? And then Jameson's going to take over and give us actually a demo of some of the data that we've captured and produced for the city and county of Denver. And then we'll open it up to questions. So, you know, I actually like to say that Sanborn was the first digital twin company. However, there was no digital capabilities back in 1866, so I had to change that term to map twin. So that's kind of a new comment or a new verb to define what we've done over the years. But we are the oldest mapping company in the United States. We've been doing maps since 1866. And we've done actually a lot of different groundbreaking work associated with capturing data and turning it into a digital representation of the Earth. And so it's been interesting to kind of look at what digital twin is and what people are thinking about from a digital twin perspective. Because when you think about mapping and GIS, it has a lot of synergies that are surrounding that. I do like to point out on the far right-hand side here an image. This is an image actually of an elementary school in Colorado Springs that was built. It's on the Sanborn map from 1916. This school is called Ivywild. And so when I talk about Sanborn being the first digital twin company, this is just kind of an example of what I'm talking about, right? We have data from as early as 1866 of structures across the United States that actually show the name of the structures, so the dimensions of the structures, even show some construction information associated with the structure itself. I particularly like this image and picked this image out because this is the elementary school that I went to here in Colorado Springs. So it's actually still here. It actually has transitioned away from being an elementary school to now being a brewery. And so I can actually go into my 4th grade classroom and drink beer. And it just so happens that that was actually on the 1916 map, not as a brewery, but as a school. So little cool fun fact about some of the maps and my involvement in Sanborn. So as a company, you know, Sanborn has always talked about the foundational data that is important to build on the geospatial value chain. And when we talk about foundational data, we're really talking about base map type of technology. So LiDAR, imagery, topographic, photogrammetric base maps. And as we work our way up this foundational pyramid and we get higher and higher up the geospatial value chain, we come to what Sanborn has always coined the term of decision support systems. A lot of times these decision support systems were very siloed in terms of what the requirements were for our customers, right? And so one example of that is a wildfire hazard assessment system that Sanborn had that was called WFRAS, right? And that system allowed for us to model the real world, model the vegetation types, model the hazard assessment components, and actually do planned mitigation efforts in a digital space. So I would say that that's actually an example of a digital twin. However, one thing that we're actually seeing nowadays that's evolving, and why we're talking about digital twins so much now, is that the digital twin map data itself is becoming the foundational layer. And so we're quickly transitioning from using ortho imagery, for example, as a base map, to these foundational visualization layers that will allow us to do more with the data. So the concept of having these siloed decision support systems is now expanding to a point where you actually have an enterprise digital twin based functionality that has multiple different avenues of support and functionality within a government agency. So you can't build a digital twin if you can't build data. So one of the things that we always point out is that Sanborn does have the capabilities to acquire all this data. So we have the aircraft, we have the digital sensors, and we have the IT infrastructure to be able to process it. So when we're talking about the digital twin, it is quite computationally expensive and excessive. And so being able to actually collect the data and process the data in an efficient manner is an important aspect of building out these digital twin products. So what is a digital twin? If you look at the first bullet on this slide, digital realistic representation of physical objects, product entities, and cities, right? So on the right-hand side here, I show kind of the foundational layers from the national map. And so really, when we think about GIS and we think about data that we've been using for 30, 40 years within the mapping business and the GIS world, really we are working within a digital twin environment. How we make that a more powerful tool instead of just having map data is that we actually interact and we bring additional information into that map data, like video content, like AVL information, anything that's essentially within the concept of Internet of Things. That allows us to essentially have the geographic information with the information system information to give us better assessment and answers to what we're doing now. So in effect, a lot of people that are on this call that have been doing GIS, you really have been working with a digital twin environment without even really knowing it. However, a lot of times that is within a 2D world. So what we're going to talk about today is how do we go from that 2D world into a 3D visualization world. So one thing I'll point out is that when we talk about digital twins, there's many, many different concepts for digital twins. In these examples here, the top image here on the left is showing, a body, right? And the different systems that are components of the body and tracking that. On the right here, we're talking about an engine and having that in a digital space. And on the bottom right there, you're talking about an aircraft and having a sample of that aircraft. On the bottom left is probably the closest of what we're really going to talk about today. And what I'm going to basically call it is a spatially enabled digital twin. So it actually is closer to what most of the people on this call are interested in, which is GIS and mapping data. Essentially, that's an image of a smart city concept. So why do we need these digital twins? Well, it allows us to do testing and do desktop assessments and do more work more efficiently and actually safer. And so these are the concepts that people like, to be able to actually run scenario planning, to be able to do design and maintenance, and to optimize our business processes through efficiencies. So controlling and analyzing this data in the real world in real time, but within a digital environment, a lot of times provides that efficiencies that we're looking for to enable improvements. So again, I'll coin this term, spatially intelligent digital twin base maps. That's what we're going to talk about today. So how do we take this remote sensing data that we have across the entire country and use that data to actually create these concepts and create these base maps? So there is a lot of existing sources that are out there that we'll talk about today. And that is actually one thing I wanted to mention before I hand it off to Srini, is that when I brought up these concepts of digital twins at NISCHIC and at other government conferences, the one thing that I think is an immediate reaction to the concept of digital twin is the idea that, hey, we know we like that idea, but it's going to be really costly. We don't really have the input data to support that right now. And I think that's something that we're going to talk about today, that, when you think about the United States and you think about the richness of the data sets that we have available now, there's a lot of ways to build the foundational components of the digital twin. And a lot of it you already have, the points, lines, and polygons, and how do we take that and evolve that into a full visualization system? And that's what we'll transition over to Srini to talk about now. So thank you.
Thank you, Jason. So we will talk about the digital twin, the creation, what sort of data that should be used, and what is that we capture, what is the level of detail, all those information we will be covering in the next slide, and subsequently I will talk about the use cases. The most important thing with regard to the digital twin base map is primarily the buildings, and within the buildings there are two important parameters or the characteristics. One is the geometry, the other one is the texture. Basically the geometry talks about the shape and the texture is more about the aesthetics of the building. So we talk about, first thing is, we talk about what sort of data that should be used for creation of the digital twin. As we all know, we handle multiple geospatial data on a day in, day out basis. It can be vertical imagery, oblique imagery, aerial LiDAR, ground-based imagery, and ground-based LiDAR, and there can be some more additional information can be available through various other sources, like crowdsourcing is another way by which we can get some data. Now, with this geospatial data, what sort of products we can get is what is shown on the right-hand side, this table. If you take between the vertical imagery and oblique imagery, we can get the geometry, and also we can get the land cover and the planimetric information from the imagery, as well as we can do the attribution to the geometry. When we say attribution, it's intelligence is being added to the geometry. For example, we capture a building and then we qualify that building, whether it is a commercial building or it's a government building, that or it is a school or something like that. So then the building has got more intelligence than just saying it's just a building. And then in the same way, we talk about the aerial LiDAR, ground-based imagery, and the ground-based LiDAR. So primarily the output is various products that can be created from any of the geospatial data, whether it is the imagery or it is the LiDAR. So with that, we get into the next slide, and I think this is a slide which shows clearly about the vertical and oblique imagery. And I think this is a oblique camera, which is primarily, it has got 5 different cameras, and we are seeing vertically down using the Nadir sensor. And in addition to that, there are 4 different sensor cameras are there at 4 different angles. 2 of them, one is seeing the forward direction, the other one is seeing in the backward direction, the other one is the left side, the other one is the right side. So together, this capture is shown in the left-hand side picture, wherein this is a vertical imagery, and this is a forward, this is the backward, and the left and right. And so together, what happens is that you get a different perspective of a given building or any other object on the ground, 5 different perspectives, including the vertical one, 4 different perspectives. So that's oblique imagery is one of the critical source for creation of the digital twin. Why it is critical, that we will explain in the subsequent slides. So here is the slide shows for a given building, how the building looks from a vertical imagery. This is something people will be doing it on a day in, day out basis. And on the right hand side, the same building viewed from one direction using the oblique camera. So this is only one direction. With the other 3 cameras, you can see the 3 different directions of the same building. So together with the 4 different directions of the same building, and as well as the vertical, we can get a complete the picture of a particular building or any other item that is in consideration. And the next one is, of course, the LiDAR. Again, the LiDAR has been used extensively thanks to the 3DEP program. We are having close to 75% to 80% of the country. We have got the LiDAR data at the minimum QL2 LiDAR data. And again, the LiDAR data will be a very very critical or very important input in the case of creation of the digital twin. And with the LiDAR, obviously, we can not only create high accuracy elevation models, but also we can create some of the derivative products that will be useful in the case of adding value to the digital twin model creation process. And now we get into the level of detail. So when we talk about the digital twin, primarily with regard to the buildings, we talk about 5 different levels. We call it as a level of detail, starting from LOD 0 to LOD 4. That means there are 5 different levels are there, and they are all shown in the figure in the bottom. So the LOD 0 is primarily a 2D footprint. LOD 1 is an extruded building. LOD 2 is an extruded building with a roof type. LOD 3 is a full architectural features, including doors, windows, etc. And LOD 4 is the interior modeling. We will go deep inside as we progress further, but just to show you, this is the the figures show you starting from LOD 0, which is primarily it's a 2D. There is no elevation is attached to the LOD 4, which has all the information, including both the exterior as well as the interior. So here is we start from LOD 0. As I said, it's a standard 2D building footprint. There is no elevation is attached. Whereas in the case of LOD 1, what we do is we capture the highest point of the building with an elevation value. So the elevation value can come either from the LiDAR or from the DSM created from the imagery, or it can be a manually created stereo compilation. Also, there are many ways by which we can get the elevation value. We call it as a sugar cube. At this time, what you are seeing on the bottom, the two figures, the left-hand side is primarily the LOD 0 with no elevation, and the right-hand side is the LOD 1 with one single point elevation. And at this time, this is only geometry. There is no texture is added. That we will talk in the subsequent slide. One of the things that we are doing is, as the building is very critical, one of the ways normally people do is to use the manual method of capturing the buildings, but we have been using the machine learning or the deep learning based the building creation. And what you are seeing in this slide is primarily 3 images. In the left-hand side image where the building density is high, the middle image where the building density is medium, where the right-hand side, the building density is very, very sparse or very limited. Despite all the cases, whether the building density is low or medium or very high, we have noticed the deep learning models was able to create the outline of the building in a proper manner. This is something, a positive result that we got over a period of time. And of course, we are still evolving with the model, as well as we are validating, we are also validating the result, because whenever you use any automated method, the most important question is what is the level of accuracy? So the validation part also is simultaneously going on. So with that, we go into the LOD2 and LOD3. As I said, LOD2 is the extruded building with roof type, and LOD3 is the full architectural features, including doors, windows, etc. What you are seeing in this figure on the top right is an example of LOD2, which is primarily the building with the roof types, whereas the bottom right is the LOD3, which includes both the doors, windows, everything. So as you can see in the model. And then once we capture the geometry, then the next question is the texture. Currently, the texture can be obtained by various methods. One is the computer-generated texture library that can be used. We can get the texture from the ortho imagery, but that will be useful only to capture the rooftop only. You will not get the side of the buildings. You will not get any information from the ortho imagery. And this is where the oblique imagery scores over the other images. You can get the texture for the side of the buildings using the oblique imagery. And then finally, you can use the geophotos. And what you are seeing in this photograph is the oblique imagery used to create the texture for the sides of a building. And again, what is the method that you are going to choose depends on various parameters, the collection methods, cost, resolution, and visual quality, etc. But in general, I mean, either it can be a computer-generated texture library, or it can be from oblique/vertical ortho imagery. So this is an example of a texture library from which is primarily created using the computer-created texture library, and you can use this texture library to add a texture to your building. That's one way of doing the things. The other way of doing the thing will be, this is what you're seeing is more realistic, in which we use the oblique imagery and use the texture from the oblique imagery for the side, and for the rooftop, as I said, we can use the vertical imagery. And this is a realistic texture obtained from the oblique as well as the vertical imagery. The other way I said is the geophoto. This is only in the case where you have to capture very few buildings. Then you can use this. It's a ground-based method. You use a ground handheld camera type of thing. Take the picture of the building from multiple locations, and then you can create the texture from that. But again, if you are going to handle only very few buildings, then this method will be useful. But if you are going to talk about a city or a town or a downtown, then obviously you have to use both the oblique as well as the vertical imagery, because you will be covering more number of buildings, and this will be a very, very time-consuming process. And as I said, the LOD 0 to the LOD 4, we can have both the geometry and texture. As I said, the texture can come from realistically from the imagery, or it can be from the texture library. One of the two things we can use to get the texture. And this is the web mesh product for the Denver downtown area. This is what we are going to show you in the demo with regard to our digital twin, which Jamison is going to show at the end. Primarily, we have used the oblique imagery and also added additional, we created the texture as well as we added additional features such as vegetation, DEM, DSM, as well as the transportation bridges. Everything has been added on the digital twin, so that we are going to demonstrate at the end. So the last one is the LOD4, which is the interior mapping. And what we are seeing on the video clipping is the interior of a conference room captured using the LiDAR scanning. There are different ways you can use capture the interior. Either it can be from the CAD building plans, it can be from the digital blueprints and modeling, or LiDAR scanning. So, you know, the LiDAR scanning means it's a tripod mounted scanner, but I think what we have done is we have gone through one step further and we have created our own technology, what we call it as a spin. It's autonomous, it's a robotic-based thing. And so that way it will get inside the building, it will capture every nook and corner of the building, wherever it has the access. And then you take the data and process the data and create the model. So this is for a conference room in a building. And with that, we get into the actual bigger building. This is what you are seeing is our Colorado Springs office. And as I said, we use the robo to capture the data. What you are seeing here is the floor plan, and what the Sanborn symbol is where the robo is moving. It has all the equipments, including the LiDAR scanner and other things, the GPS, everything. Once the data is collected, you take it and process it and create a model. So with that, I think we talked about the geospatial data that is used for creation of the digital twin. What are the things that we need to consider in terms of creating a digital twin in terms of geometry and texture? And then now we talk about the most important thing. One is, as Jason said, creating a digital twin is one thing, but what are the use cases? That is what every user would like to know. What will be the level of involvement or the level of effort? And then what is most importantly, what is the return on investment? We do believe the digital twin can be used in various use cases, and primarily we talk about certain few things in this presentation. One is the property valuational and risk assessment, the next NG 911, next gen 911, as well as the emergency response. Transportation is another area, urban planning, energy consumption. We can show you a slide how the digital twin will be useful. With regard to the facility management, we can do, it can be map every floor, stair, elevators, etc., monitor location of the people, and then it can be used in the document management also. And finally, the most important thing where we see the digital twin will have a very good use is in the autonomous vehicle driving, specifically in the case of HD maps. That also we will talk about that. So let us take the first one is the property valuation. What we see as the users are the occupancy / the rent history, the location discovery, and the virtual tour. These are all the users of a property, the digital twin in the case of property valuation. Because it is used for the virtual tour, it can be used in the case of, it can be used as a visual executive decision support tool, as well as it can provide us the better property return on investment as well as lower cost. Also, it can provide various information in terms of financial history, trends, property valuation, and so on and so forth. That will enable us to create various graphs or various charts, what we are seeing on the left-hand side, like the overall vacancy rate, return trends, and the rent trends, etc. That will be very useful in the case of any decision-making process. So we see the property valuation is one area where the digital twin will be immensely helpful. The next one is obviously the risk analysis. And one of the important aspect of the risk analysis is primarily on the asset vulnerability, whether it is a flood or any other natural disaster, whether a particular property is vulnerable to any natural disaster. And also it can provide information on the value based on location proximity, risk from community or parcel vulnerability to fire, flood, hurricane. That's what I talked about. And also we can perform the peril risk analysis. These are all some of the main uses of the digital twin in the case of risk analysis. This is another critical area we see digital twin will have an important role. Once we have a 3D digital twin, both the interior and exterior of a building, that's a modeling, and we do have the address location data. One of the critical things that in the current scenario people expect is just locating a person both in the horizontal and vertical areas, in the sense if there is a building is there and it has got multiple floors, and if each floor has got multiple rooms, obviously, then if there is a phone call comes from a particular person in a particular room, if you know the XYZ values, you can straight away attach to the particular room in that building. So that way the next gen 911 process will be more efficient and faster. So that is what we see. Definitely the digital twin has got an important role to play in the next gen 911. And the next byproduct of this next gen 911, I would not call byproduct, it's another use of the use case for the digital twin will be in the case of emergency response. Since we will have all the information with regard to your building, like doorways, emergency exit, fire extinguisher, light switches, etc., it is easy for the people to plan for the evacuations as well as response to any terrorism related activity. So this is another area where we think definitely digital twin will play a critical role. Then the next one is the autonomous driving. This is what I said at the beginning. We use the navigational maps on a day in, day out basis whenever we drive. But the HD maps, we call it as intelligent maps or high definition maps, is totally different from a navigation map in the sense it has got all the information that you see on the road when you're driving, you will see on the HD maps. So basically including signs, poles, buildings, sidewalks, crosswalks, overpass and barriers, vegetation, every information you see when you're driving on the road, that will be captured as a part of the HD maps. And so it adds intelligence to the data. It provides information on the direction of the traffic flow. And also it gives you information on the type of sign, whether it is a speed sign, turn or restriction warning, etc. So it's this digital twin will have a very, very important use case in the case of autonomous driving. And this is one of the project we did in the country of Qatar, wherein we have created a digital twin. What you are seeing on the left-hand side, on the right-hand side are the two maps. Basically, we have captured all the assets within the area of interest. And what you are seeing the maps on the left-hand side, on the right-hand side are the 2D maps. And what you are seeing here is the visual representation of the complete asset information of the property that we are able to capture using the imagery and the other ground-based information. So this is done by Sanborn in the country of Qatar. The next one is the energy analysis. This is another area where we think digital twin will have a role. What we call it as they determine the insolation, that is the power of the sun. So if you have a building, we will have the basic information like the building height, the slope of the roof, the compass direction, what are the surrounding buildings, what is the height of the surrounding buildings, and what is the shadow area that is being created by the surrounding buildings. All those information we can get, and that will be very useful in the case of performing the energy analysis. So this is another area where we think the digital twin will play an important role. And and tourism is very natural thing for digital twin to play a role. As you can see, you can have a point and query, augmented reality tools, or it can be a 3D directories. So anything connected with the tourism, whether it's a virtual tourism or a restaurant directories or advertising shopping assistant, anything connected with the tourism, the digital twin will have a role to play. And this is a emergency response. What we have done here is we have taken the automated vehicle location. So what we are seeing here, the vehicle is moving, that location has been built, and using that, we have created this model. This is another area where the digital twin will play an important role. And this is sort of our last slide before we go on to the demo. As Jason said, the digital twin is combining all the data sets, whatever that is available, to create one single model or an object. And as I said, we are right now, we are using mostly aerial images and aerial LiDAR and ground-based images and LiDAR, but there is going to be more geospatial data is going to come in various forms. And we do believe this digital twin is going to improve further and further when we get more geospatial data in various form, various resolution, and various accuracies. So definitely this process is going to improve, and we are going to get better digital twin models going forward. So with that, I believe I think I can hand over to Jamison to show the digital twin that we created for the Denver metro area. What we have used primarily, the oblique as well as the vertical imagery is what we have used. We have captured, as I said, we have captured all the buildings as well as the DSM, DEM, as well as the vegetation. Everything has been captured, including the transportation. The process is more or less 100% automated using the tools what we add. And when we saw the results were really encouraging, and we saw most of the places the results were extremely good. But there may be very few areas, there may be few anomalies people may notice. But as I said, this entire process is done in an automated manner. And wherever few anomalies we can see, those can be easily addressed by a manual editing or something like that. So that way you can have a very clean digital twin model. With that introduction, I think I will hand over to Jamison.
Okay, can everybody see my screen?
Yes.
Okay, perfect. So what we're going to be looking at today is we're going to be looking at Denver proper. So this is going to be the Denver metro area and everything around it. And so the outline here that you're looking at, this is going to be a spatial package that's been reproduced into an Esri format of the digital twin of Denver. Now, this was produced outside of an ArcGIS and Esri platform, but for this purpose and as well as sharing it to other agencies and organizations, this will probably be the most optimal way today. And as I said, in sharing, you're able to basically produce this digital twin, and then you're able to share it, whether it be through Arc Online or Arc Enterprise, and you can share it to anybody within your organization or within an agency or anything like that, and they're able to actually use the data and play with it and add in their own data and have their own use case for it. So like I said, this is kind of an overview. So we're going to spend the next few minutes kind of looking at some of the more popular or attractive sites within Denver. So the first one is going to be Mile High Stadium. So you can kind of see the level of detail here. So you're able to see the scoreboards, you're able to see the Bronco logo on the actual stadium itself. And then you can kind of, play around and you can see the streets and you can see all the parking lots and everything like that. Then you also have the bridge with the river and everything. So this is kind of a good representation of a larger object and the detail that it can provide. For the next one, we are looking at the State Capitol building. So this was in Srini's slides, but this is kind of a more close-up version of it. So you can kind of see the level of detail on a close-up with the vegetation and the streets and the buildings and everything within a close proximity. You can kind of see that the level of detail is still going to be there, and you can also use a lot of it as a tool for public works or whatever case you may need for it. And then the last one is going to be the Arts Museum down here in Denver. So the reason we picked this one is because it's kind of a funky building, right? So it's got a lot of weird shapes and weird dimensions. But we wanted to show that even the LiDAR and the obliques and everything are able to pick up the finer details and the sides and the points and everything. So you even have your pedestrian walkway here. So we'll kind of go into the use case now. So we'll start with the building shadows. So we picked this one because if you're going to be repurposing a building, or if you're going to be expanding on a city or something like that, building a new road or something, it's important to understand the environment around it, right? So what's going to be the sun temperatures, the sun angles, the line of sight, things like that. So you're able to kind of see from this point of view that, you can kind of see what type of, pavement and sun angles and sight lines and everything that come into it. And then when you're talking about building like a residential building or something like that, it's important to understand what the sun angles and the line of sights and everything for the buildings around it are going to be. So this provides you an opportunity to kind of see in a real live sense what type of what type of a larger building is going to have an impact on the smaller buildings around it. So you're able to kind of see what a larger skyscraper does to a smaller building such as this. So this is kind of an apartment complex here in downtown Denver. So you can kind of see that, you know, midday or early in the morning that it's going to have a shadow effect on that type of building. And so if we go into like the traffic accidents portion of this, so this is an intersection here in Denver, and we picked this specific one because it's kind of a unique situation where you have smaller buildings with medium-sized buildings, but you have a lot of mature trees, and you don't have a lot of available space to expand on if you need to. So what we were able to do here is we pulled up a 2D point map of the traffic accidents that happened within the city of Denver over the last 5 or 10 years. And so this gives you kind of a representation on a spatial level of what type of accidents are happening and what type of day and all that stuff. So if we look at this specific one right here, you can select it and you can see that, you know, you have 2 accidents here that happened. And so this specific one happened in 2017. It gives you the cross streets of it, gives you the neighborhood, it gives you the actual accident that happened. Gives you the vehicles that were involved. So in this sense, it's a pickup truck and a trailer. The details of it kind of gives you the day and the time. So it kind of lets you know that, you know, if an intersection is more dangerous during the day or night, if there's blind spots, if there's shadows that are creating illusions or anything like that, you're able to kind of see that. And then from a 3D space, you know, from a city standpoint, if you're evaluating whether or not you wanted to put a traffic signal in there, you know, you can throw a 2D. So this is a traffic signal for the twin area. So you can kind of see this little red dot here. There's already a traffic signal. So you can kind of see when you're planning to put something in, or if you think something needs to change, you're able to actually, you know, zoom in and see, you know, how an area looks. And you know, from there you can decide from your desktop potentially if it's going to be the easiest or best case for you. So if we go to tree inventory, so this is going to be a city park in downtown Denver. So we chose this one because you're able to kind of see the level of detail with all the mature trees and the different pathways and the grass and different things like that, and then the roadway going into it. So if we pull in the tree inventory, so this is going to be a 2D representation. So this is a point map of all the different trees that were collected and categorized within the city of Denver. So if we just select on this one right here, you can tell what type of tree it is. It gives you the species and the type. It actually gives you the diameter and it gives you how many stems. So it's going to be one tree. It gives you the park location. It gives you the inventory that it was done. And then it you know, it allows you to better understand the situation. And so when you go and look at these places, it's not like you're looking at a tree from a 2D space. You're actually able to zoom in and kind of see on a true level, on a 3D level, of how large that tree is or how large that space is. So if we go to the manholes and the street lights, so this specific example is a good example. It was chosen because this is kind of a residential area, but you do have some mixed use properties here on this main road here. But the biggest thing here is you have a lot of mature trees. And so there's going to be a lot of canopy coverage and there's going to be a lot of shadows that are put in play here that can block asset management and asset collection for your utilities for the city. So these are going to be manholes and streetlights throughout the city. So these are going to be sanitary and storm drains that were collected throughout the city. They're going to be yellow. And the orange are going to be the streetlights throughout the city. So you can kind of see here from a 2D standpoint, a lot of these might be difficult to see just because, you know, they're going to be covered by a tree canopy, or you can't see them with a shadow, or because of the type of ortho that was collected, it may not be so obvious. So you're able to actually zoom in on some of these areas at a street level, and you can actually see, you know, what type of manhole or anything or anything like that you're able to view into. So this gives you a better opportunity to understand what you're looking at, and you can do it from your desk. You don't necessarily have to go out and put you know, boots to pavement. And then this one, so Sanborn does a city set for the different buildings. So this is going to be a different one. This is going to be for downtown Denver. So the red buildings that you're seeing, these are singled out buildings that are either going to be abandoned or they're going to be hotels. So all of the various different red ones. So all of these are going to be categorized, but we selected these out just to show you a couple. So if we zoom in on the First National Hotel, so it's going to be this guy right here. If we turn this off, actually, let me select it real fast. So you can see that it's the First National Bank. You can see the street name and type. It gives you the occupation, which is going to be a hotel. It gives you the type of construction and the exterior, and it tells you whether or not it's going to be fireproof or the type of construction that it was done. Gives you the type of floors, the height, the square footage. It gives you all the different addresses within that specific building. And so there's a ton of information in this that you can actually use. And so if we zoom in on it, you can kind of see that it's going to be kind of a close area, but you're able to you're able to see the different details and shadows and type of situations that you might see in the real world. So now if we go to an abandoned building, so this is going to be an abandoned building kind of maybe 4 or 5 blocks away. So it's going to be this one right here. So if we turn on our cityscapes and we select it, you can see that it used to be an Evans Public School building. It gives you the year that it's built, tells you that it's abandoned. It gives you the same type of construction, whether it be you know, brick or fireproof or anything like that. It gives you the height, the stories, the square footage, gives you the primary address. So this, I feel like this could be useful because if you're looking at you know, various unused buildings throughout cities, you're able to actually see this from a 3D standpoint, and you're actually able to see what it looks like and what its use case could be from your desktop. And you don't necessarily have to go out and see it in a 3D space with your own eyes. You can see it on a computer screen, and it gives you a better idea of what you're looking at. So this is, you know, this is kind of a type of situation. And then the last one is going to be our parcels and bridges. So we chose this one because it's a good bridge. It gives you the overall height and the dimensions of the gantry here for I-25. It gives you the railroads and the bridge going over it, as well as the parking lots and everything underneath. And if we overlay a 2D parcel map for it, this is a 2D parcel map of all of Denver proper. So it basically breaks down all the different parcels and their extents throughout the city. So we're going to be looking at this one right here. So you can see it's city, county of Denver. You can see the address of it. You can see the actual name and everything like that. Gives you the department, gives you the and then if we go further down, gives you the land value, gives you the day and the time and everything like that that's been evaluated. So you're able to see when it was last purchased. You're able to see when it was last valued. So when you're doing assessments and stuff like that, and you notice that, you know, whether it be a commercial or residential area that might have improved or gotten bigger, and you're doing an assessment to see if taxes need to be raised. A lot of times, you know, in the past, I've helped with that. You do orthos and you do change detections based on the year to year, and it gives you an idea of what's changed, and then you go out and you do an assessment and you decide whether or not the taxes get raised or not. From this standpoint, you're able to actually get interactive with it, and so you can actually do a measurement of certain areas, and you can do line or square footage, so you can do planar or geodetic. And so, you know, if you're looking at a certain area and you need to get a quick look at it before you go out, or if you'd even need to go out, you can zoom in at this point and you can actually see what's changed. You can do a year to year if you had digital twins for 2 separate years, and you can examine and measure from your desktop and decide whether or not, you know, that assessment is warranted or not. And then from there, you're able to, you know, do what you do. But from this standpoint, it has a lot of different use cases. You're able to do a lot with it. And so we use this a lot from the GIS standpoint, and it's very useful because you're able to combine a lot of different systems and a lot of different factors and use it as one use case. So that's kind of the demo that we were looking at. I could stop presenting, or if somebody wanted me to pan around a little bit more, I'm more than happy to. But I didn't know if Jason wanted to open up the floor for discussion or questions or anything like that.
Yeah, actually, that was great. Thank you so much, Jameson. Yeah, I think we could actually leave it on the screen in case someone does want to pan around and open up to questions if there are any.
Just a reminder, guys, if you do have questions, put them in the chat box and I'd be glad to read them out loud.
Sounds like silence there, Amy, huh?
So we have one from Karen. She asked, are you seeing adoption of this at city scales as opposed to state scales? If mostly at city scales, about what size of the city?
Yeah, I think it's a great question, Karen. Obviously, this is NISJIC, and so trying to show value at a state level versus a city level is important. You know, to the extent that we have here, we have the modeling that is essentially giving you every single building. I don't see that necessarily being at a state scale for someone like the state of Wyoming, right? Other populated states like New Jersey might be a different story, but you know, I think what we see for a state of Wyoming, though, is that you still could have some level of a digital twin that actually does have some capabilities from a visualization perspective, especially when you think about the amount of data that you've just gotten, for example, the LiDAR data, right? So combining that with some imagery data, combining that with land use information, and being able to essentially set that up in a visualization tool like Esri would empower some of the digital twin concepts that we just discussed here. So similar to a lot of the GIS data, it's a little different depending on what the use case is, but trying to come up with multiple use cases for an individual or a single digital twin is really, I think, the messaging coming out of this presentation. So hopefully that answers the question there. Yeah, and that's another point I think that you're making there, which is the fact that, you know, maybe you have a larger digital twin for the entire state that is specifically for natural resources and oil and gas and things of that nature, and then it would zoom into a higher detailed digital twin base map concept for the city of Cheyenne, right? So I think there's different ways of scaling it so that it can be a single kind of platform that can be used and have multiple people using it and adopting it for their individual needs. So.
We have one question from Jess. I see 3D and indoor GIS as the future of geo-enabled elections similar to E911. Where are people inside of residential buildings? Do you know if any election departments are using this to help with determining where voters are actually located in buildings that may be split by precincts?
You know, Jess, that's a very interesting question. I'm not aware of people using that for geo-enabled elections right now. You know, I think it does cross over into a discussion that's broader than probably just GIS data. Obviously, we can actually collect data in interior to buildings, but when we're talking about residential buildings and private buildings, there's a privacy component associated with that. But I see the driving force for that interior work right now being E911. And so again, the concept that we're presenting here is the fact that can you build it once and use it many times for different resources? You know, so if E911 is going to have that capability within their tool sets, are we able to essentially use that same base map to support some of the concepts that you're presenting there? It's interesting that you actually have a building that is split by precinct. I'm not sure if I've seen that one before, but I'm sure it's happened. So a conundrum for sure. So.
And Karen had a follow-up question. Are you working with your clients to document the ROI?
We are. I think the biggest message coming out of this also is the fact that there's a lot of existing data that allows you to move to the visualization level of a digital twin. And so, you know, again, as I talked with you and many at the NISJIC conference over the last several years and this concept, I think the biggest concern is always about the cost. And is there a way to leverage existing data to build out these products to lower the cost, which therefore increases the ROI? And that's exactly right. I think everything that we do from a geospatial side of things is connected to an ROI. And how do you, show that value to your customers? It's one thing to have really cool visualization data, but if it doesn't do anything for you in terms of increasing efficiencies of your business processes, then it's not really that valuable, right? So, that's always our goal. Obviously, there's a few that are easier than others. The concept of taking this approach, Jameson presented kind of the last use case is similar to what we see right now with our standard oblique imagery, where you can kind of spin around a building and see these still photographs of an individual building, and then you can do these desktop assessments. We have a lot of clients that use our Sanborn oblique analyst to do that now. But the idea of taking that to the next level in using the 3D so that it increases the efficiencies and gives you a little bit more real world perspective than a still photograph is something that is an easier ROI to prove versus a different type of ROI, right? So, but anything that has to do with generating revenue and anything that has to do with increasing the safety of the personnel are the kind of the two biggest driving factors on the front end of these types of technologies.
And then Jared Fisher writes, I missed the beginning, so apologies if this is repeat, but how time intensive is it to create these digital twins? Thinking about developing data sets each year.
Yeah, so the one that you're looking at here that Jameson is panning through, this was a purely automated digital twin, right? So once we captured the data, we plug it into our software and run it through. And so because it's so automated, it's really efficient. It's not a significant cost. And it actually provides some pretty fundamental or phenomenal type of visualization. Now, we can always go in and clean it up and make it even look better, but that always ties back to the ROI. So the other thing I would point out to you, Jared, is the fact that we do have the ability to go in and actually update components of the digital twin. So if you're familiar with updates to planimetric mapping, for example, we can go in, essentially run a level of change detection, and then go in and actually create an update for a component of the digital twin, so you're not having to rebuild it every year.
So it looks like that was our last question. We do have like a few more minutes. If anyone else would like to post their questions in the chat box to be read aloud, give them a minute to. All right. Last call. So we have two. Jared also writes, have you tried this on other landscape?
Yeah, I mean, the digital twin concept can be used in a wide range of locations. So when we think about mines, we've done a ton of work over the years to provide volumetric calculations and changes and things of that nature. That typically is not as much of a visualization type of product, but has been a calculation type of product. But to be able to enable that as a visualization layer would be relatively easy, because the source data is already being collected typically for mines, trash sites, things of that nature. So depending on what that physical landscape looks like, there's no reason that it wouldn't work. And actually, in some cases, it might be a little bit easier because you don't have as much of what I call the urban mess that you see here in Denver and Colorado Springs and other locations like this. So.
And then our last question is from F. Shelton. Do you see any agencies using this for stock ponds?
So I'll have to talk to you a little bit more about that. I think it's a more complex question. So when you say stock ponds, are you asking about below the surface water, or I'd have to have a better understanding of what specifically you're looking at. So I'd be happy to take that offline. We have our emails are published here with NSGIC, and we'd be happy to follow up with you specifically about that use case. So, all right, thanks. And Karen, you're right, urban mess, yeah, it's always fun. I was going to make a comment. Jameson was showing that I-25, and he mentioned parking lot. It looked like a parking lot in the one direction on that image, so it's kind of funny. But anyways, we appreciate everybody's time. And again, if you do have questions, feel free to follow up with any of us. We'll look forward to talking to you guys in the future. And to the NSGIC team, appreciate you making this happen. Thank you so much. So.
Yes, thank you to all three of you for such a wonderful presentation. I would like to note that if anyone does have any follow-up questions, you can also send them to info@nsgic.org, and I will be sure to hand those off to the Sanborn team. So once again, thank you to our presenters for this wonderful presentation. And thank you for all for coming to the webinar today. We appreciate your participation. So with that, I hope everyone has a good afternoon.
Thanks, everybody. Bye. Thank you, Amy.